So we have an equation for sine and cosine. I'm just going to write it down here. There are 4 letters in our equation for sine and cosine. I apologize for the students in class. My Apple TV is so slow right now. Everybody at home, you're seeing everything in live time and they're like 10 seconds behind in class. So we have one final letter to talk about, and that's the D. And then we have our A and the sine, and then bx minus c. This D is the part that moves the graph up or moves the graph down. It can be written in the front. It also can be written in the back, and it just depends on how the author chooses to write the D value. So that would be my K if I had a parabola, at adding it up or down, shifting it up or down. It's the vertical shift of the graph. That's the sinusoidal axis, so that fancy name. The middle of the graph is the sinusoidal axis. It's like the horizontal line that goes through the graph. Kind of, it's invisible. Think of the axis of symmetry for a parabola. This is the same thing, but it's horizontal. So it's this horizontal piece that goes through the middle of the graph. That sinusoidal axis happens at the D value. So I'm going to take the problem we just did. I'm going to come up here to the equation, and I'm going to add a +1 to the back. That +1 is my vertical shift. That's the D value. So if you look at the current graph, the x-axis is like the sinusoidal axis. I'm just dashing it in so you can see it. But like, think of that as this middle line. It's kind of like the horizontal line of symmetry. I have the same above and I have the same below. That middle line shifts up or down depending on the value for D. So we are going to use this graph and see if we can get it to shift. So the +1, Kaden, what do you think that would do to every point on your graph? Move it up 1. So with your graph, I'm going to take every point and move it up 1 because that's what this +1 does. It tells us to move the graph up 1. So each point moves up 1. Now make sure you're moving it up 1. Remember, 1 is really 3 blocks. The shape of the graph shouldn't change. The stretch of the graph shouldn't change. It just moved up 1. So when I connect my points, I now have a vertical shift. And that sinusoidal axis, or the center of the graph, is now up at 1. That's all that the D value does to the graph. So it takes everything and it adds 1 to it. When I graph a function that has a vertical shift, I usually graph it exactly as I just did right now. I graph the original function so that I'm not worried about what it's doing vertically, moving it up or down. And then I literally graph a second one showing that shift so I can physically see how the graph shifted up or down. That's the only difference from everything we've done so far. That little extra added piece to the graph shifts it up or down. Does anybody have questions? So that D value moves the graph vertically. It's a vertical shift. It helps you find the sinusoidal axis, which is kind of like the line of symmetry in a parabola, but it's a horizontal line cutting the graph in half. So that's like where all my x-intercepts should fall. If they were x-intercepts on this line, notice that they're falling on that sinusoidal axis. Any questions? So as I said, I wanted to start the homework with you today. And I thought I would do 59. The first problem is actually 56, but I'm going to let you do that one because it didn't have a vertical shift. And I just wanted to do one more with you so you could kind of see the vertical shift. So however you keep your homework, if you want to open a new slide, I have the problem up here already written down. It's a cosine function, so we could do a cosine function together since we just did a sine. So if you want to open a slide for your homework, or is the assignment posted? I don't know. Let me open the assignment so that if you want to use that. All right, so the assignment should be posted if you wanted to use the graph paper there. But this is number 59. It's a cosine function. It has a -4 in front. And then it has +5 times the cosine. And this one ended up having a t in it instead of an x. So 5 cosine 11t over 12. And I thought this was a good one to do because what an evil fraction, 11/12. So I thought it would be a nice one for us to look at. We'll just kind of go through it, and then you have a homework problem done. You have another problem practiced, and this one's cosine instead of sine. So thinking about the letters, that number in front is D. Notice this problem is in front. And then the addition sign, so that's when you know that it's being added. Anything added or subtracted shifts it vertically. The A is the 5 because that's what's multiplying cosine. A always multiplies the function. And then the B is multiplying the variable. The B always is multiplying that angle. So my A value is 5. My B value is 11/12. The period is 2 pi over B, or 2 pi over 11/12. Which means I need to multiply by the reciprocal. Maybe that's a pi. Hold on. Oh. It is a pi. I was going to say, that's going to be absolutely horrible. I missed the little hook thing. Sorry, this is a pi. Phew. Get that pi back there. Sorry, Jenny, you're working ahead. Anybody that was working slightly ahead, I apologize. I was thinking 11/12 is going to be absolutely horrible. So that should be 12 and then over pi, multiplying by the reciprocal. So Jeremy, what does that make our period? 24. That's a pretty big period. So our period is 24. This is a huge stretch of the graph. And then Jeremy, what are we going to end up counting by to get from one point to the next? It's going to be 6, yeah. So take that 24, divide it by 4, and we're going to count by 6. Questions so far? So I'm going to ignore the -4. And I'm going to just graph this exactly as we just did the last graph. So this -4, I know it's there. We're going to do that last. Grant, is there a phase shift in this graph so it's shifting left or right? Why not?
Because there's no C value.
Awesome. Very good. No C value. So Grant, that means the first angle starts at 0. And then if I look at the Y, my A is 5. So we're multiplying the Y by 5. So I would have the 5, 0, negative 5, 0, and then 5. Jenny, what angles do we have for using 6 as a counting value to get up to 24?
We have 6, 12, 18, and then 24.
And then 24. It's kind of nice. You don't have a fraction to worry about. It looked like it should have been evil. Thank goodness that 11 wasn't there. Does anybody have questions so far with anything we've done? So we multiplied y by 5 because there was a 5 in front of cosine. We're using the ordered pairs for cosine. It's a cosine function. The period was 24. We divided it by 4 to get all the angles. And then I'm just, because there's no phase shift, I'm going to go over 3 and just call that 6. So essentially, each one of these boxes, we're counting by 2s for each box on our graph. 24 is pretty big. We would need double the graph to let each box represent 1. Now, careful with this. My A value is 5, but then we're also going to be shifting things. So on the y-axis, I'm just going to count by 1s because that A value is a pretty tall stretch. So I'm going to just say 1, 2, 3, 4, right here is 5. And again, the reason I'm doing that is because this D is going to move my graph up or down. And I want to make sure the entire graph can fit. So I'm actually just labeling the y-axis, counting each block representing 1. We usually don't do that, but because of that number 5 being so large, the A value being large, we will still see that vertical stretch. So it starts at 5. Cosine looks like a U, just kind of a U that has curves at the top. Cosine does the same because it's even. So I should have the same graph on the left and right of the y-axis. It has y-axis symmetry. So there's my wonderful looking graph. Any questions about graphing with the A and the B value, the amplitude and the period? All right, let's look at that last part. What is the -4 going to do to our graph? Grant, what do you think? What's it going to do to the graph?
Go down 4.
Yeah, so the D value is -4. That's going to shift every point down 4. So every one of my points should shift 4 spots, 4 boxes, vertically down. If you physically want to show that in your ordered pairs, you can, but you don't have to do that. So I already have a graph drawn. I'm just shifting my points down 4 units. And that's all a vertical shift does to any function, whether it's a trig function or an algebraic function. It shifts your graph down or up. Each point moves down or up. So it didn't stretch more, it didn't shrink more because of that vertical shift. And then I can see this little line in the center of the graph. That's that sinusoidal axis. It's usually the x-axis where all of the intercepts are passing through. That line has now shifted down to y equals -4 because of the vertical shift. Are there questions with that extra piece added to the graph? So there are 10 minutes remaining, which I'm glad because that was my goal to at least get you 10 minutes. The homework is in the book, and I can pull out some books for you guys who are here in the classroom. If you're at home, if you have questions, feel free to remain on. Otherwise, you've got 10 minutes to start practicing through some of the problems. Have an awesome weekend, everybody at home. I'll see you if you're in group A on Monday, and Monday is another practice day. We'll probably go through like one of the homework problems again, and then we'll start a homework problem maybe, or we'll just kind of practice on Monday as well. Of course, yeah. Have a good day, everybody at home.
Promise, Kane. Have a good weekend.
Have a good weekend.